Hey, applied 30. We're in our last week before spring break. I know it kind of feels like you're on it already, but we're gonna work our butts off until we get there. We got a few more things to look into stats. Today I want to tell you about something called standard deviation. I'm gonna go on the document camera for that as well. Again, sorry about the watermark on the top, but we're gonna deal with that. Just because it's a lot easier to deal with on a computer than it is on the board. But I'm still gonna show you something on the board. I want to get your opinion on it. I've got an equation here. What is it? I've got an equation here that I like a lot. If your parents aren't mathy people, you might want to show them that and spook them a little bit because it's not too bad. And I assume that you're a little bit uncomfortable by this, but that's our topic for today. We're going to learn how to work with this equation. And not only that, I'm going to show you how you can make a computer do that equation for you so you don't have to worry about it. Okay? This is something called standard deviation. It tells us the dispersion between our data, and it helps us understand if a mean, for example, is an accurate representation of that person's data, or if it's a little bit more sporadic. For example, if we're looking at somebody taking three-point shots in basketball, and they sometimes make it and sometimes don't, our standard deviation will help us understand how accurate that person actually is, not just based on their score. So it seems a little bit odd, a little bit hard to wrap your heads around. That's because we don't know what it is yet. But by the end of today's lesson, I think you'll understand this equation a lot better, and I hope by using the computer, you'll be able to use that equation a lot more easily than having to in your head. All right, so we'll see you in the document camera. Alrighty, so back to the document camera. And we're going to talk about standard deviation. So we went over the equation on the board. It looks a little bit confusing, but we're going to work through an example to understand what standard deviation is. What might be useful is if we start with a definition. So standard deviation, this is a measure of, I guess, a dispersion of data from the mean. What that means is that we can understand how accurately a mean represents a set of data. If we have a very high standard deviation, it means that our average tends to bounce around quite a bit. Our average is calculated from values that bounce around quite a bit. If we have a very low standard deviation, it means that our data is very consistent. And that helps us with certainty. So we would rather have a more certain set of data because then we can make predictions based on that, but that isn't always necessarily possible. And the standard deviation will help us understand the confidence in certain values. But let's work through an example to understand this a little bit better. This is actually right out of your textbook. It's on page 226. We're looking at the field goal percentage in the last 10 basketball games for these three players. Now, I didn't want to overwhelm you with just numbers, so I blanked the table first, but now I'm going to fill them with numbers. Again, this is from 226 if you wanted to follow along. And boom. These are everyone's shooting percentages in the last 10 basketball games. Now, imagine a scenario. Let's say you're in a championship game, and your best player is hurt, and you've got these 5 girls on your bench. One of them has to go on. Who is probably your best bet to throw onto the court to help you in this championship game? Well, there's a few players that stand out to me. First one is Morgan. And that's because their shooting percentage is pretty good sometimes. She's the only one with 40% or higher scores. And that's pretty good. It's just her data is very sporadic. Like, I don't know if I'm getting the 48 Morgan or if I'm getting the 19 Morgan, right? The other person that stands out to me is Paige. And the reason why Paige stands out is because her data is very uniform. It's very similar. Like, each and every single point is very close to that 34, 33, 35 mark. So I might be better off taking Paige. Now, I have a hunch that she's going to have the lowest standard deviation because her data seems to all fit in the same spot. She's very consistent with her shooting. So let's calculate her standard deviation, and then I'll show you an easier way to do it. So this is just Paige's stats. I've just moved them up to the top. And I've got a calculation here. I've taken her field goals and made them vertical. I've got a calculation here for her deviation and for her squared deviation. And you'll notice in the deviation, the formula is x minus x bar. And x bar was our average, it's our mean calculation. So we add up all the values on top of the equation, and we divide by the number of data points we have in total. So 34 plus 35 plus 33 plus 35, so on and so forth. All that divided by 10, you end up getting a number of 33.9. So her deviation is going to be 34, which is her x value, minus 33.9, and that equals 0.1. And I can do that for 35 as well. 35 minus 33.9 equals 1.1. Okay, and you can do that for every single one of the values. You can also square the values once you've done that. So 0.1 squared, 0.1 squared, that is equal to 0.01, and 1.1 squared is equal to 1.21. You might want a calculator for calculating square values. I don't expect you to know all that. But we would have to do that for every single one of Paige's data points. Because I'm such a nice guy, I've done it for you. Okay, so all of our values are here. You might want to pause the video and get those ones down, just so that you have that information there. And then we can move on to our next calculation. And that is called the mean variance. So it's still x bar, which is x mean, and there's a subscript of VAR, which stands for variance. What we're doing is we're adding up all of the squared deviation and dividing by the total number of data points, so it's still 10 data points, and that gives us a value of 0.69. And we want that number because the variance, the average variance, is needed to calculate standard deviation. That's what our whole goal here is. So standard deviation, the symbol for that is sigma. It's a lowercase Greek s. That is calculated when you take the square root of your mean variance. So we take the square root of 0.69. We end up getting plus or minus 0.83. Okay, so that's a long-winded way of calculating standard deviation, and you do need to know how to work through that, so I'll give you some practice on it, but there's an easier way to do these types of calculations. We just switch over to Excel for a second, and I recommend getting comfortable with Excel. It's very useful. I've got the table listed here. I just smushed it. I've got Paige in yellow, and our calculated standard deviation is 0.83. The easy way to do it is on Excel, hit the equals button, and then type in ST. That takes you to standardization. We're looking for the deviation, so STDEV, so standard deviation, dot P. This is a special type of deviation called population standard deviation, so we're going to do that one. You're going to open a bracket and highlight all of Paige's data points. Then close the bracket and hit enter. And would you look at that? It calculates a standard deviation for us. So we should be able to do that for everyone else. I'm just going to click on the little box in the corner here and drag it onto Anna, Patrice, and Morgan. Calculates their standard deviation, and I'm going to calculate star as well. So you look at all their scores. Yeah, Paige is very consistent. She has a standard deviation that's very close to 0. That's a good, consistent set of data. Morgan, who seems to have the highest shooting percentage, has a very high standard deviation. So we don't know if we're getting that 50% shooter or if we're getting a 40% shooter or less. So maybe not the best situation if you're picking Morgan. If you want consistency, Paige is the person to go with. Now, for your practice, I recommend doing some of the questions by hand. That way you understand the material a little bit better. But once you've done it 1 or 2 times, if you want to use Excel or you can use some other technology, I'm totally cool with that. So for your practice, I've got a couple of questions over here. Oops, didn't want to do that. Where are they? Down here. Let's move them back up here. It's going to be on page 233, numbers 1, 4, 5, 7, 10, 13, and 14. Take your time with these. I'll give you a couple of days to work on them, and if you have any questions, feel free to let me know. All right, good luck.